are fully funded by the government. So all we have to do is pick the students. So we don't have to generate funds for the students. So the faculty members here, you can see, we are all very relaxed. So all the work gets done by the students, we do only the talking, and we don't have to generate funds for them. So that's one great advantage of the Indian education system. However, these number of seats are extremely limited, as you can imagine, compared to the size of the country and compared to the competition that we have. Then we have the PhD program, regular PhD program. This is the same for both science as well as engineering, the PhD program. The MS program that I mentioned is only for engineering. The ME and MTech program that I mentioned is also only for engineering. The science people have an integrated PhD program which goes for about 5 to 6 years. With the regular PhD program that I'm just talking about now is after the master's degree, either in science or in engineering. In engineering, we also give the options to really talented undergraduate students who have just completed their bachelor's in engineering to opt for direct PhD. So there is an option for the BTech or the undergraduate students to go into PhD directly, or they can go through the master's degree and then convert it into. Now the PhD here is quite rigorous. It takes typically about 4.5 to 5 years. And we have a very strict comprehensive examination in place after the student completes around 2 years. So the comprehensive examination has to, this is similar to the US system. And many of the students who cannot make it into the comprehensive examination, they either leave the institute without a degree, or we have now introduced an exit route by which we give them the master's, that is MS degree, and then they take the MS degree and go. The PhD students typically, we expect a very high quality of research contributions, and we expect typically 2 to 3 good publications. This is a recent expectation.
So we did there is, in addition to playing street cricket, we went to Elephanta, we went to an ISKCON temple and watched a wedding. Yes, we went to Dharavi, and that was an interesting experience for everyone here. Then we spent several days in Hawaii, and there was very strong interaction with IIT Bombay. And in fact, we have had interactions with so many centers and departments. Of course, helped strongly by your ex-student, we all know very well. And in multiple areas, so civil, nanotech, Center for Urban Sciences, Center for Rural Technologies, Center for Energy Sciences, so wide mix. Then we came to Bangalore, and here we are at IIMD, Indian Institute of Management in Bangalore, and today we are here. Tomorrow we are going to Dr. Rao. Yes. Yes, so we'll go there, and then we'll have a climate change warning. Climate change warning. So I'll tell you, that will require some really wide knowledge. And then we'll go to Kerala. We'll spend some time there. Yes, so hopefully we'll catch the onset of the monsoon. Although this time we are hearing that we'll leave Kerala on the 3rd. This time we are hearing from Sahana's research. And actually we are collaborating with this research that Majumdar and his students is leading on the onset of monsoon. They actually saw all of them there. And Sahana is going to be embedded with us when we are in Kerala. And then we go to Delhi and Agra. We stay there for 3 days. Because what I heard is that if we come to India and don't go to the Taj Mahal, we'll have mutiny.
Yeah. They won't forgive you.
Yeah. So that's the goal.
So by and large, the students are happy about the expedition. Would they want to say anything about their experience? Any of you about the Indian experience?
It's nothing we can accept. don't really get a very good overall view of the area. I've gotten some like response and stuff with them, so it's really not determining of the whole academic program, obviously, and financial and stuff. This has been really awesome for the sale aspects. I think Lily's doing a very good job making sure we see every facet of the performance. Yeah,
She was in Cambodia before.
Yeah, I was in Cambodia before, and I think one of the things I've noticed that was different was I've seen a lot of passion for the things we've met a lot of great faculty members who are really interested in what they're doing, and I met a lot of great Cambodians, but not, at least in the climate change area, I didn't meet too many people who are really.
We are in the southeast of Asia, and we have a major contribution to our water resources come from monsoons. I'll give you some details about that. So this is essentially the location, and precisely because of its location, the climate change issues are important for us. So, most of our water resources, when I talk about climate change, it's mainly related with water resources. Most of our water resources come from a number of river basins. We have a large number of river basins, some of which are really large in size. For example, you have the Indus Basin here. I'll talk a bit about the Indus Basin. You have Ganga Basin here. Ganga River, this is a major river. And there is a Brahmaputra River. Mahanadi is here. Narmada this side. Then Krishna, Penna, Kaveri. So these are our major sources of water. Whenever we talk about either the climate change issues or water resources issues, we need to keep this in mind that most of our water resources come from rivers. Now the Indus River is an international river. We share the Indus River water resources with Pakistan. And just for your information, the Indus Water Treaty, which has been in existence for almost a century now, 70 to 80 years, has never been broken in spite of political tensions leading to wars. Even during the war time, the Indus Water Treaty has never been broken. So this is a great credit to both India as well as Pakistan. Similarly, we have the Brahmaputra River, which we are sharing with Bangladesh. So wherever there are international rivers, you are aware that there will be tensions about sharing of water. The Colombia Water Compact, Colorado Water Compact, this is an example that you may be, where 7 states share the water resources with Colorado. So this gives you some general idea. These are really huge numbers, just very broad and rough estimates. Our annual rainfall, average rainfall is about 900 millimeters. Now, when I say average rainfall is of 900 millimeters, you must realize that there is a huge spatial variability in the rainfall, and that is what causes problem. As you can see here, it goes from as much as 800 to 1000 somewhere here in Assam, to down to almost negligible rainfall. So this spatial variation is what causes water resources problems. Unless we are able to store the water, we are unable to get the use of. Similarly, temperature, there is a huge variation, but as you can suspect, most of these temperatures are above 25 also the country. There are some sections here, Himalayan region, where the temperatures are quite main water resources come, as I said, from the surface water, and therefore we need to store the water. So these are our major dams. For example, we have the Hirakud here. Then on the Narmada river we have several dams. Bhakra Nangal is a huge dam, classical dam, where the waters of Bhakra Nangal have actually changed the Punjab region totally. It was for wheat cultivation, and then so on. These waters are used. So Bakranangal is a major dam. Then you have Hirakud here on Mahanadi. On Damodar Valley there are several major dams. On Krishna there are several dams. And Kaveri there are several major dams and so on. Now much like the international rivers, whenever there are rivers between two nations, we have, this may be surprising to many of you, we have interstate conflicts. Whenever a river crosses boundaries of two or more states, we have conflicts among the states. And these conflicts are often extremely emotional issues, and they cause a lot of social upheavals. For example, you take Kaveri River, the waters are shared between Karnataka and Tamil Nadu. And the farmers in both these, you must also remember that irrigation or agriculture is the major water user in our country, and a large section of population depends on agriculture for their sustenance. So there are interstate conflicts. For Narmada waters are shared between Madhya Pradesh, Gujarat, Maharashtra and Madhya Pradesh, Gujarat, Maharashtra and Rajasthan. So 4 states. So there is a water sharing agreement among these 4 states. Alright, so whenever we talk about water resources, whenever we talk about India, the first thing you should address is the population. The first stress comes from the huge rate of increase in the population. So as you can see from there, for the last about 100 years, if you go up to 2050, that's the population increase, and we are somewhere here now. We have already come to about 1.3 billion. And if you look at, if you take a bird's eye view, so much of population, so much amount of water available. As the population increases, the all India per capita and water availability is decreasing. Alright, so this is the first stress that we need to look at. The second stress comes from the fact that most of this water is used for agriculture purposes. About 70 to 80% of the water is used for agriculture purposes. As you can see from there, the other requirements like industrial, domestic, etc., they are extremely small compared to the agricultural water requirement. And whenever we talk about water resources in India, therefore, we need to look at both population growth as well as the use in agriculture. And unfortunately, as of now, the country is staring almost at a impending water crisis because of the poor or unscientific way in which the water resources are managed. So the water resources are already stressed now in as far as the management of resources is concerned, and also in as much as the increase in population as well as increase in the demands. Climate change will be overlaid on this existing stress, and that is likely to bring additional stress. So whenever we talk about climate change impacts on water resources, we must understand that we are talking about the climate change adding to the stress that already exists on the current water systems. For example, there is a rapid urbanization taking place in the country. You look at Bangalore, huge urbanization has taken place over the last about 10 to 15 years, and which stresses the water systems. There is no scope for expansion of the water infrastructure, and this is happening everywhere. Urban floodings have become a major issue. Just an increase of intensities by a small margin, the whole city gets flooded. So this is becoming quite common. There are huge water stresses during summer. There are many localities where there is a water shortage and so on. So these are the stresses that already exist. And we do not have a groundwater law. And to encourage the agriculture, the electricity for pumping groundwater is provided at a subsidized rate. Actually, in some situations, it's almost free. So the farmers are free to use the groundwater, to pump the groundwater whenever electricity is available. As a result of which, the groundwater levels have gone to unsustainable levels in many areas. In addition, the groundwater is also polluted both because of anthropogenic as well as because of geogenic or the natural causes. There are several areas, several pockets where We have fluoride and arsenic contamination. Many places in Karnataka also there is a fluoride contamination and so on. So the groundwater is polluted. Large number of river systems are polluted beyond acceptable levels. Water shortages occur. Floods occur. We have floods and droughts that I have a figure for. There are large number of areas which are drought prone, large number of areas which are flood prone. Now these are all existing situations as of now. So these are the current stresses on which now we have to superlay the issues related to climate change. You please feel free to stop me anytime. So I know you can just read that. Yeah.
Can you talk about international water sharing? What happens in Nepal, India, over the Kosi River, not River, always get river everywhere. So there is no agreement of water management there in Nepal, India.
I think on Kosi there is no agreement. I'll tell you about Indus as well as Brahmaputra. Brahmaputra we have Teesta River. On Teesta River, India and Bangladesh have been trying for a long time to arrive at an agreement. I think just about 2 years ago they almost reached an agreement, but it has not been finalized. However, the Indus Water Treaty between India and Pakistan has been in existence for 70 to 80 years and it has worked perfectly well. In fact, it is cited as one of the ideal cases of international river sharing. Maybe because Nepal and India are more friendly countries, perhaps this has not happened. But between Nepal and India, especially for Kosi, I think the only cooperation that I am aware of for Kosi is on the Kosi flooding. Kosi flooding, both India and Nepal have a joint monitoring commission. Because you must be aware that Kosi gets flooded quite frequently, almost every year. And there is a joint monitoring committee. In fact, I have visited when it happened in 2010 or something. The engineering team also works together. So there is a joint team which is monitoring the flooding. Otherwise, there is no water sharing agreement. Now, at this point, I am happy to introduce my colleague, Professor Shekhar. I want to introduce you.
Hi,
He is my
good afternoon. I was held up elsewhere, so hi,
you can just
welcome
introduce
you all.
yourself.
Oh, I work in the faculty as a faculty in the Department of Civil Engineering, work in the Water Resources and Hydrology group. My specialization is more on hydrogeology. I worked on modeling experiments, catchment hydrology. Any questions?
Okay, so we'll just progress. I just have 9 slides. I'll take another 5 minutes perhaps. So that
One question, Dennis, if you can tell them a little bit about the urbanization impacts also.
I'll come to that.
You mentioned that there's some issues with groundwater contamination and arsenic. Are there any ongoing projects, research projects right now looking at that?
Yeah, maybe Shekhar will add, but groundwater contamination, especially arsenic contamination as well as fluoride contamination, there are a large number of projects that are going on in the country. There are also international collaborative projects. I think some 5-6 nations together are addressing the contamination in that northern side that I just showed, somewhere this region. Maybe Shekhar will add.
About the arsenic?
Arsenic and fluoride contamination, whether there are any research projects that are going on.
I think there are a few, some coordinated by the Indian groups working in Bengal itself. There are some international. There was an initiative with MIT and Harvard with the groups in both Bangladesh and in West Bengal. They were doing a lot of work on that. Mainly these are all on arsenic. Fluoride, I think it's more scattered across the country because you have in southern India some spots, western India also you have many spots of fluoride. So there are not many coordinated projects from national interest, but there are individual researchers joined together working on fluoride. But there are other contaminants, for example, metal mining issues, which are essentially Karnataka is one source, some other parts of where there's acid mine drainage issues. So, for example, there's a group working in IISc looking at minimizing the acid production potential in mines, which is through bacteria and so on. so that, for example, these are the pH of waters produced are very low, to the order of 1, 2, and so on. So much of it microbial. So how to control the microbes and so on. That's something which there are some interest now more on nitrates now. So because India is producing large, I mean, we buy and produce for food. So fertilizers being applied across the, so a lot of nitrate pollution. So how to reduce these impacts? There are a lot of groups working. Sorry, hi.
You mentioned about this collaboration on arsenic and others with the universities in the Boston area.
Yeah.
So I don't know if you're already working with Shafiqul Islam, who is at Tufts. But what we are doing, this is for the medical here as well. So that Shafiq has been leading this effort with others at other universities in the Boston area, including Northeastern, Harvard, MIT, Boston University, many UMasses, and now we also have UConn in the mix, University of Connecticut. So they are calling this Boston Water. And some of us in the faculty, some of our graduate students, some people from the industry and federal agencies, they've just started to meet once every month, talk about these things. These include people who have been working in Shafiq is originally from Bangladesh. And a lot of focus also on South Asia, and a lot of focus in general on water sector worldwide, especially water in mega cities and so on. So a lot of things happening in the Boston area and in collaboration with South Asia.
I would also like to add, the Indian funding agencies, research funding agencies, are also sensitized on this particular issue. So there are a large number of calls every almost couple of years, 3 years, etc., on addressing these soil contamination as well as groundwater contamination. So generally there is a sensitization, but still the problem persists. So the problems are quite active.
There is a practical aspect to it. In the villages where I work, near here, we find fluoride contamination, mostly by looking at kids and the teeth marks and the joints. So then there is the state subsidizes filtering plants. So we set up, there are NGOs that also set up filters to remove fluoride, but that has to be then followed up by, so that's done with groundwater mining again, to do rainwater harvesting to recharge. So other than research, there's a lot of practical, just on the ground solutions that are being implemented.
Okay, so we'll just progress now. On the climate change issue, as I just start off the discussion. As I said, there are already water stresses now that are occurring, and on top of this now, we are talking about the stresses introduced, additional stresses introduced by climate. So the three prominent signals of climate change, as you can see, are the ones related with the increase in temperature. The second one is precipitation patterns changing all across the globe, and the sea levels rising. Now, as you can see, all of these have direct implications on water resources. For example, your river flows will change, groundwater recharge may change, and your demands may change, and so on. So we need to address these issues vis-a-vis climate change when we are talking about impacts on water resources. Shekhar, for your information, this group consists of civil engineering and the science students as well as policy students. So there's a good mix of students. So we can talk about all aspects. So when you are looking at our country, as I said, we have a long coastline here. First of all, when your sea levels rise with excess pumping of fresh water already taking place, there is a salinity intrusion. There is a salt water intrusion phase. This keeps moving inside as excess water gets pumped in. On top of that, if you also raise the sea levels now, the gradients increase and therefore it pushes further inland. So salinity intrusion as the result of sea level rise is an important issue. Apart from coastal flooding, as the sea levels rise, the coastal areas get flooded and so on. So these are some of the issues. So when we talk about our country then, as I said, primarily the water is used for agricultural purposes. So the first level question that we ask is, how do the water flows respond to these global climate events? Because the river water is our major source of water. Whether the flows are going to come down or are they going to increase or the future, let's say next about 3 to 4 decades, that's the first level question. The second associated question is whether floods and droughts, which are the hydraulic extremes, what happens to the magnitude, frequencies, intensities of floods and droughts. So this is the second level. Then we also talk about water quality. As some of you are mentioning, surface water contamination is also an extremely important issue in our country, where there are effluents coming from cities as well as industries. And unlike most of the developed countries, we have to live with this for a long time. That's the effluents keep coming and they are only increasing.
On this, I can transfer the uncertainty in these parameters to the return levels. So at present, I am working on this IDF relationships and getting the uncertainties in the parameters. Of the, for this, I am working on the Bangalore city rainfall data. And for Bangalore city rainfall data, the generalized extreme value distribution fits the model for the data. So I am working with the parameters of the GB right now.
To initiate some discussions, let me ask a few questions. This area is of extreme interest to us, and we are actually working on this. So tell us a little bit so that all of us can understand two sides of what you're doing. So you talked about the core, which is exactly what you're doing. One part is, so you're working with models, right, to be able to get into the future, as you said. So can you physically interpret, or is there a plan to physically interpret what is causing the changes, if any, that you're seeing in IDF curves? That's one side of it. The other side of it is, from an engineering and policy and design perspective, can you explain what the implications are for these changes in IDF curves that you are observing or may observe? So two sides. One is physical interpretation, other is implication for policy and design.
Yeah,
I think just to help her, I'll ask her to address the second point. First point, maybe I can add a bit.
yeah. The implication wise, especially in the urban areas, the short duration and high intensity rainfall creates flooding, and then getting the uncertainties in this short duration high intensity rainfall is required. So the implication of this is that the heavy flooding is occurring in Bangalore city. Even for 5 minutes rainfall with even 10 mm per hour, the city gets flooded, and then a lot of traffic jams.
The point is, how do you assess that? If the intensity increases, then how do you assess the impacts on flooding? You have done it, SWM or some hydrologic model, you convert that into hydrographs.
Yeah, so this intensity, the intensity with the corresponding duration and the return period, the IDF curves are transformed into the design hydrographs, input hydrographs, and it has been the drainage system of the Bangalore city, and we selected a valley in the one part of the Bangalore, and then the IDF curves are transformed into the design input hydrograph, and then we assess the areas of critical areas of flooding.
So in the US, for example, we have the IISc, American Society of Civil Engineers design manuals, right? And they start with these IDF curves, and then say, okay, in the city, here's how much reinforcement you should put on your design for dams, levees, whatever hydraulic infrastructure you need to put, right? And there was actually one capstone project that was done by, people who were senior to this batch, who in civil engineering, who actually used some data from Santa Cruz in Mumbai and elsewhere to look at IDF curves and see how these things change. is there an equivalent of the IISc design manual here, and do some of these things then inform some of those design manuals?
In IS Indian Standard Design Manuals are also there.
We have what is called, sorry, you would not know that. I will just keep on. This is NDMA, that is National Disaster Management Agency. This is a government agency. They have developed guidelines for urban flooding. So the hydraulic designs of the drainage systems, as well as the outfalls, all the gated structures that we provide, all of these have been specified in those guidelines. But on a research mode, what we do is that for different intensities, now as the intensities increase, we create a hydrologic model of the city complete with the DEMs and all of that, and show how the flooding is likely to increase because of these changes. Now through our ITRA project, which you are also aware, we are addressing that in a big way, urban flooding in the event of climate change. And as to your first part of the question, which is related to the physical aspect, in this what we have done is, we have also looked at the urban heat island effect in some very non-rigorous way. We simply look at the distribution of temperature all around non-urban area and look at the temperature distribution here within the city, and then show that the temperatures are in fact significantly different within. But whether this is causing the high intensity rainfall or there is some other natural process that is happening, that we are addressing in the project, where Dev Niyogi is our partner. So he will develop convective system forecast, and then we will examine its implication on the ground.
Thank you.
Ishwar?
Hi, I'm Ishwar, working with Prof. Shekhar. So, giving us a broad overview, I just tried to give a broad overview of the research in my group. So, in our department, each faculty member will have a core to 2 or 3 teams as a core research interest, and all the students will work in different sides of those core 2 teams. So, like, say for example, Professor Majumdar mostly concentrates on climate change, its uncertainties and its effects on water sources. Like that, in our group, we concentrate on different parts of the hydrological cycle and spatialization like things. So, the main area is try to assess the different components of hydrological cycle through remote sensing estimates is our prime area, and try to link each of them, how they are influencing each other. And also we have developed a catchment on our own, a research catchment, south part of Karnataka, in which all these kind of different variables are observed and they are modeled differently. Say, I am working on modeling evapotranspiration. My colleague called Subhash is working on modeling rainfall. So each of the students take one hydrological variables and try to see how to model it using remote sensing and validated point estimates, so that we get an overall spatial estimates, because the hydrological variables are certainly complex in terms of its both spatial and temporal variability. So in order to get both of them, we need to have good estimates from remote sensing measurements, because point measurements won't help. They will be too much concentrated at one point. So to overcome those limitations, we try to take different variables and try to establish remote sensing based methods and spatialize them, and try to apply them in models to find out the integrated effects of how they are behaving. Say for example, we have observations on soil moisture, evapotranspiration, rainfall, groundwater, everything, and combining them with anthropogenic activities also, we try to examine how the water cycle as a whole is evolving in the place over a period of time in that particular place. So it can be more called of a catchment hydrology experiments, where we take a catchment, observe different variables in that particular catchment, try to model them as an integrated manner, and try to see how it progresses in time and what are the different effects. So this was a broad overview, I can say.
So one question which is to all of you and to Raghu also, again will help I think all of our students, is so this is interesting. So we talked about IDF cars, which is implications for engineering design. We're talking about watershed scale hydrology, and some of us and many students here are trying to understand the impacts of climate change on that with models. So what's your view? So Raghu, is one of the major climate modelers, climate scientists world. So what's your view in terms of how would how much models, GCMs, global models is of course where we start, and then we go to regional models. What is the situation with Indian monsoon? What can be done with those? Anything from your perspective?
Yeah, so let me start here. There is a paper in review from another institute in India, for example, which looked at all the monsoon projections. In their conclusion, the title itself says that CMIP 5 monsoon projections are not reliable. So what we try to do is, there is IPCC class models which are CMIP 5, which are really useful for, let's say, global governance issues. You are worried about what kind of temperature limit you want to have in 50 years, what is the different pathways you can take to keep it there, RCP 8.5, 2.5, whatever. So a lot of things go into it: population, technology, adaptation, mitigation, and so on. So what we focus on is something called regional Earth system model. So what essentially has to happen is, even the dynamical processes like convection, for example, rainfall, over India it's very different if you go to the west of the Western Ghats and if you go to the east of the Western Ghats. The processes are very different dynamically, so you have to represent them. Plus, when you have cities, the land use of the cities has to be represented so that you know the effect of urban heat island and the land surface change on the storms that are coming in and the local intensity, even the diurnal peak, whether it will happen during the day in a rural area versus urban area, and so on. So the regional Earth system models try to do this regional specificity of the processes. Right? So they represent all the details of the land model. They try to capture the multiple physics that are involved in what determines the convection. So if you think about US, for example, the rainfall that happens over the breadbasket in Wisconsin will be very different than what happens in Miami. So the same model cannot necessarily capture both. So you have to have multiple physics. Plus you have to represent the fact that Wisconsin is agricultural land, whereas Miami is mostly urban. And Miami is close to water and Wisconsin is not, and so on. So in the Indian monsoon, this is a very complicated issue because you have so much ocean, and it's a very warm ocean, and it's warming much more rapidly than any other part of the world. Then you have Himalayas to the north, which makes a big difference. So you cannot do anything with the monsoon unless you represent this complex terrain, including the ocean, and how they are changing. So to get reliability of these kind of projections, the idea is to go from time scales of weather to what are called extended range, because rainfall here, if you are lucky and you get to see the rainfall in Kerala, when it starts, it might actually rain for 3 weeks or something. But if you are lucky, you will see what is called a break period, where rainfall starts, it pours like hell, then it stops for some time. So the seasonal rainfall is made up of these active and break spells and so on. So to do this urban flooding problem or agriculture or water resource management, dams, whatever you have to be able to capture these large-scale distributions, then bring them down to literally city scales. So it's not just about increasing the resolution of the models for those who understand models. It's actually capturing the regional specificities of how the land and atmosphere and ocean and atmosphere and ocean and land are exchanging energies. So you have to have rivers, soil moisture, vegetation, whether it's agriculture or forest, Western Ghats, the hills, Himalayas, and so on. So I think the future of global modeling is really not so much in just running CMIP 5 and keep increasing resolution of CMIP 5, but to have a system that is almost like two-tier, where they do what they do at global scales and they do capture all the major modes. They have something like a monsoon, they have an El Nino, they have all the other things. And then you have to take it and make it very region specific. And then you have to be aware that there is a syndrome called garbage in, garbage out, which means if your global model is producing garbage, then your regional model will not be able to produce too much else other than a garbage out of it. But the regional specificities it's called adding skill or enhancing skill or adding value. So monsoon is a typical example of a system that I think will never be fully captured in global model. So we must set up a very good regional bus system model.
They apply on the land and they become, the governments are asking, the agencies are asking. So there is a direct connection.
Okay, I suggest, so that's a little bit better, that this will require. What they do require is the sensitivity of the people who are involved, and with an intensely human face, you need to develop your science. The science that particular pocket needs is a very low level in terms of rigor, but a very high level of human sensitivity. So I think at some level you will achieve this, and I have seen Raghu's work in North Karnataka and all that. So this really is a personal choice, and I have seen many people who, after spending some time in research, doing high quality research, they also enter into this kind of. Just the last point that you were mentioning about what was that? Making research a community, which is related to what you are saying. If we start combining these two at the PhD level, let us say that I want to do something for the benefit of the society. If you start mixing the two, especially in the areas that we work on, then the rigor has to come down. Rigor will come down. So what we do is to achieve a balance. As far as PhD program is concerned, you just go full hog into just doing research. But as you are growing inside, you will start connecting yourself with the society. And that connection comes as you grow as a person. And there the training that you have gone through, the rigor of PhD training that you have gone through, will help you in addressing the problems, understanding the problems correctly. So I think without undermining the rigor of research in PhD, you can still retain and sustain and sort of grow the sensitivity towards the society. And institutes like this, sitting in institutes like this, we cannot afford to relax and say that I will do only this much and not further. Because there are very few institutes, very few people for the type of problems that we have, for the type of huge society that we have. So we need to be doing everything. Do top class research, at the same time do what is possible on the earth.
So one question on that is, in the case of Israel, for example, and I know there is a lot of difference between Israel versus India, but in the case of Israel, that choice for some reason doesn't have to be made. I mean, Israel science is top class, and their engineering solutions are top class. So this difference that you're saying, this rigor versus this versus thing, does it come in India partially because of resources?
I would say this comes only in some institutes like this, because our primary purpose of our existence is to do research at the highest level.
Same for technology or for
But the type of problems that they face also feed into the highest level of research. Whereas our type of problems are mainly because of policy issues, bad management, and someone not putting enough time or thought into these things. So that's what maybe Raghu will add.
Yeah, I mean, it's like the scale of economy, right? I think there are some social things here. Social theory said very clearly that when a society has faced resource limitations and adversity, their norms and punishments tend to be very strong. Right? So Israel, it's a scale issue. It's a small, homogeneous society with a lot of resources coming from outside. They get several $billion from the US. Well, India is a huge country with culture changes from, I don't even understand what Arpita is saying half the time because she's from West Bengal. So these issues have to be dealt with. So Israel is, yes, it's a successful story, but for a very different reason. You have to do it on the ground with your own money and so on. And it's very different. And US is very different because they haven't faced the kind of resource limitations that India has faced. So if you look at small scales, India has similar success stories. If you look at a large scale, it looks like a chaotic place with so many things not working. Rajasthan is better than Israel, what Rajendra Singh is doing. So go there, right? So don't look at just the broad picture. If you pick scales, it is done. I mean, what Rajendra Singh has done in Rajasthan is a miracle.
Well, I mean, it doesn't strike me necessarily as if that this research isn't use inspired. I mean, you're studying a monsoon, and right? I mean, it's not sort of pure math or something. So it's certainly
Last
very
mile
socially
connectivity.
relevant.
Last mile
Yeah,
connectivity is
exactly.
what
Yeah.
I mean.
Yeah.
That is what is necessary. And in fact, with Raghu and all, we are trying to build some groups now, international proposals, where we will do that, build it right up to the society. I think that sensitivity exists. How much of it gets translated into the action needs to be seen.
But there are examples also, right, when very top class research from places like this have actually led to transformative benefits down the line. It's always hard to say that this research, basic research, will immediately benefit in a lot of ways. Unless there are any other questions?